Welcome to Clean Classics. This little series is all about giving the information to you guys whether you're going to get someone like ourselves to convert a vehicle for you or whether you're going to try and do your own EV build on a classic car. And this is the EV conversion checklist part 1. This time we're going to talk about weight in the vehicle. So one of the most important things to consider when converting a classic car or any car for that matter is weight. You know, traditional swapping out of an engine for a more powerful one, whilst the engine might be a different weight, you're going to be putting it in the same place in the car. You know, it's the balance and the weight is going to be staying relatively similar. With EVs, it all gets changed up a bit more, and it's really worth thinking about where that weight's going to be going. Rather than the actual thing producing the torque and the power to drive you forwards having all the weight in it, it's actually the fuel storage mechanism, i.e. the batteries, that are the heavy, bulky bit, and they can be positioned anywhere in the car, relatively speaking. So there's various things that need to be considered when laying the batteries out and the weight of the vehicle. So the first overall thing to be thinking about in terms of positioning those batteries is you want to have the centre of gravity of the car as close to the centre and as low down as possible for the sort of best balance. You want to minimise really heavy objects being put outside of wheelbases if possible, especially if the original car wasn't designed to have that. That's another thing, is the balance of the car wants to be kept aligned with the original balance of the car. The chassis and the suspension, everything is working around a sort of predefined and designed weight balance. If you go changing that up too drastically, that's going to be very detrimental in terms of the ride characteristics. Could potentially create a dangerous vehicle to drive. So, you know, some cars are more 50-50, like an MX-5. Land Rovers are typically a little bit forwards biased, and things like Porsches are you know, they're designed over having a lot of weight over the rear end. All comes into the design of the chassis and the suspension geometry and all of that. So keeping that in mind when laying everything out is really important. The original balance wants to be your target. The idea behind that is there's no sense in making any of these old cars worse. If you're putting all this effort and resource into modernising it, you've got the opportunity now to actually position that weight in such a way that it's actually going to improve the car. But all of these things need to be considered to achieve that. Overall weight as well is another thing that's important to keep in mind. We generally go by the rule that if you keep within 10% of the original weight of the vehicle, you're going to be all right to maintain the original suspension design, and brakes and things will be bolstered by the regenerative braking. So 10% is a good number to say. If we're below that, we're all right to keep everything original. If you're going above a 10% weight increase, then it would be a very good idea to review every part of the car structure to make sure that you're not overwhelming a part of it, and it's going to become dangerous. In terms of the layout of our Land Rovers, starting in the engine bay, the thing you see underneath is the top box. That's got all of our high voltage contactors, our ECUs, basically all of the serviceable items. The control systems are all housed under there for easy access. They're sat on top of a small front battery pack, which is in the area where the front of the engine would have been. Behind that and really low in the engine bay is the motor, which is linked via a prop shaft to the transfer box. That transfer box is sitting underneath the seat box in the car, so it's quite central there. And either side of that are two bigger battery packs that actually go where the old fuel tanks used to sit. And then the last thing, moving right to the back of the car, we hang the charging system. We actually call it the PDM, the power distribution module, but it's got the AC charger and the DC to DC. All of the sort of power management happens back there. It's a lighter weight thing that we can just tuck right at the back there. So that contributes to that sort of the weight being concentrated into the centre of the vehicle. And what that's doing is helping the vehicle be able to turn. You don't have inertias getting in your way of actually getting the vehicle around a corner. Yeah, it's an old Land Rover, but it needs all the help it can get, really. And then the weight increase on our system, this system here, which is now our only system, is the 40 kilowatt hour. That puts us up to about 100 kilos more, depending on each car's its own thing. But it's like having a larger passenger on board. But that's well within that 10% that we've talked about. So now we feel like we've got the balance just right, really, with the way up between amount of batteries and range versus drivability. So I think we've got the best sweet spot for this vehicle. In terms of what we've put into our Clean Classics Land Rover system, we have that balance, the vehicle balance. We're still forward biased, but we've moved it slightly more central, and critically we moved it quite a bit lower. And actually you can feel that when you drive it on the road. It feels really a lot more planted than the originals. It's by no means is it a handling sports car, but it just gives you that confidence to drive it a bit more like a modern car and less like an old tractor, really. Thanks for watching. Come back for part 2, where we're going to have a talk about the voltage and the power of an EV conversion vehicle. And as always, please do like and subscribe.